This is going to be an introduction to Git. So we are going to cover all these topics. What's Git? Who is this presentation for? Who is aimed to learn Git? We will review Sourcetree main view. So it's the tool we will use mainly for Git. And then we will start different topics internally of Git. So what are commits and branches? The difference between remote and local, and how is everything saved, and also about the development side, how we want to implement features and how these features will be merged into the main branch, for example, development. So in the side of what's presentation for, it's about people that works with Git, but usually don't do coding. So, for example, artists and designers and UX. So nowadays, these people usually work in Git, but they have some doubts about how to totally work with them, and sometimes they are not totally confident about the things they can do, or if they can lose work. So that's something that coding people usually have to solve anyway, because Git is a tool especially prepared for coding, but we will also try to cover for people that use Git but don't code. And the objectives of the presentation also is it will be an introduction, really basic. So probably you will know almost everything I will show in this presentation if you usually work with Git. So don't worry. If you at the end have more doubts or whatever, we can do another SIP explaining more advanced topics of Git. And also the other objective of the presentation is to understand the purpose of the control version and the difference between a backup or whatever. And also this presentation could be useful as a documentation for Git basic. So you can refer to this presentation later if you have any doubts. And then we will start about what's Git. That's the first part. It's like the formal definition, so we will not read everything here. But in general, what I'm going to say that Git is a distributed version control system. So that's all important. So going to the side of version control system, what this means is a system that allows you to work in history. So every day you do some work and you push that work to the repository, and you are able to go back in history. So all the work you done are not lost. So you can go back and forth between all the work you have done in the timeline. And also the distributed part, what's important is to know that the difference between distributed and other systems is that you can work without internet. So in Git, you have all the mechanisms you require to work on your computer. So if you lose internet, you will be able still to navigate between history. You will be able to create new commits. You will be able to prepare everything. So when you go have internet again, you will able to share your work with your teammates. And just to a clear cover, so there are other systems, as we said, that are not Git. So for example, CVS, CVN, and that are not distributed. So the main problem of these systems is that they are centralized. So every time in Subversion and CVS, the main problem, one of the main problems is that every time you have to change in the history timeline, you have to connect to a server to download all the history. And if you lose internet, that will be a problem because you have to start again. And yeah, in Git that doesn't happen because you have everything on your computer, and also you know there are other also tools that I have never used, but they are Mercurial that also distributed, and P-Force that I think a great part of the game developers use it. I've seen problems, but I've never used it. So this site is only you know that there are other systems that they try to solve the similar problems that Git is solving. So it's another control version control systems, but you'll know them. And okay, going to the next topic, also an introductory is the Git provider. So yeah, when you are in a project, probably that repository or the project you are working on will be provided by a client. So they could have different servers, some say, where the code is actually put is available. So these are three of the main Git providers we are using, but there are more. And as I said, in Git is a distributed system. So this means that you have all the tools in your computer. This Git provider is only a central point, so everyone can connect there to get a copy of that repository. You also could work with locally or whatever, but just to let you know that these are the main repositories. So it's like another collect you have. So if you have two people working a project, every one of them will have a clone of the repository, but there also will be another clone that is the server, the main repository. And yeah, and also about clients or programs. These are the tools we use to work with Git. We here on Starloop work with Sourcetree mainly. It's working pretty fine. It has some bugs and sometimes gets stuck at some points, but I think it's pretty useful and nice. So you don't need to type commands to work with Git. But yeah, there's another tools, so probably you can try them. For example, Fork it appears to be a great tool that doesn't have so many bugs like Sourcetree. Okay, and so that's the basics about the presentation. So usually when you want to start working on a project, you will require a repository. So the repository is the place where all the files will be stored. And usually, you have two ways to start a repository: is by creating a repository or by cloning it. And usually, the creation part you will never do it because it's usually done in the provider website, and usually the client will do it for you. But you can go there and type a name for a repo. So it's like a folder created in a server, and you will have everything here there. So that's usually you don't do it. But if you want to test Git locally, if you want to try the things we can learn here, in Sourcetree you have also the option to create a repository in your computer. So it's like a folder, and you can do everything there, and you can drop if you lose or whatever. And also the other part, the other way to start a project is by cloning it. That's the most common way. So usually when you go to a Git provider like GitHub, you can go to code and you can get a link to the repository. So when you go to Sourcetree, you can type that link, and you define a folder in your computer where this repository will be downloaded. So when you clone a repository, as I said before, it's like a copy of what all the things in the server are, and somehow when you clone it, you make a copy, but it still points to to the repository. So it's like a copy that is sharing a connection. And so after, I will just show it, but after cloning, all you will have is like something like that, or clean or correct. So you will have in Sourcetree, you will see an empty file status screen, a window, and in the window Explorer, you will only see a hidden Git file, a folder, where you don't usually have to touch anything here. But this folder just means that this folder is managed by Git. So all the files you touch here will be somehow synchronized with Git. That's something just to show you, because I haven't shown you the UI of Sourcetree, but you usually have tabs where you have different repositories. In my case, I have remote and local, so they are the scenarios we will cover today. But when you click New tab, you can have these options like cloning. So you can type here the URLs you can get from GitHub. And you can also create it. As I said, you can create a local one to test. Okay, I will try to close this code. And as I said, you can create local repositories, but you can also clone local repositories. So if you want to actually test all the features in Git without having a Git provider account or whatever, you can do it locally. So that's what I'm going to do today. So I've created a remote repository. I've created a repository and I cloned it locally, and I will show you how it works. So before going deeply into what's Git and whatever, we can also cover a little bit what are the different views Sourcetree have. So as I said, when you clone the repository, you will have this screen. So you will not see anything here. It's like there's no files. In my case, I already created some files, but we will cover later why you don't see anything here. And also, you have the history tab. So here in the workspace, you have file status, history. And in history, you will see the different points in the history of your project with everything you have done. If you click at a specific point in the history, that's so-called commits, you will see something similar to file status. I will probably show you a little bit better. So for example, if that's my repository, and as you see, if I go to file status, it's saying that there's no files because it's showing pending. If I add a new file, if I add a new file, the file will appear here. And also in history, we will cover later on what's happening here. But in history, if I click on history, you will see that another point appears, another potential commit appears that also is showing a file status here. So it's showing the same information we have here. But this only happens if I click on here. If I click on a past commit, it's showing the action we did in the past. So it's showing the file changed and different information. And also you have another view that that's the search view. So you can also search by different criteria. So like the message. So every time you do a commit in the history, you have a description. So for example, here it says commit 5 test. So I can go here and search by commit, and they appear different commit. Also, I can search by authors. So I can say me because the only one, and I can also search by file changes. So I can search for internally in a file what I've changed. So and it will show it as a list instead of a graph like history. But this file changes is doing is searching inside the file. So in this case, I've removed Swarman and added Archer and that stuff. So that's the basic view you will have in Sourcetree. Also important to note that you have branches. That's we'll cover later, but you have local branches here and remote branches here. So every time you click on a branch, the history tab will appear and will point to that point in the history. So if I click on master, I will move automatically to master. If I click on local master, it's the same as remote master, so it will point to the same point. And that's it. We'll continue with the slides. So that's what we say, the history menu, the remote, and the search category. And yeah, and here I will cover a little bit more what's the file status. So before going to commits, something really important to understand is how Git is local, working with your files locally. As I've done before, when I'm right now in development, let's say for a moment we won't explain that, but I'm on a branch, on a point in the history called development. And when I go to history, I don't see anything. But if I click here and I click all, it's going to show me all the files in the repository. So it's the same we have here. I can order by name. So it's the same. And you when you work with Git, and you code, you don't usually need to know all the files. You don't usually need to see all the files there in a repository. You only need to see what's pending. Pending is similar to what's changed. So if I create a new file, it's going to say it's going to tell me that a new file has been added. So it's showing it with no tracked, and no tracked is something new, or something that wasn't before in Git. If I edit a file like Swarman, I can say that's the definition of a Swarman. So I created text files simulating what's coding, but yeah, let's show, for example. So if I made a change on a previous modified file, it's going to show me in a different color. So it's showing me that this file has been modified, and this one is purple because it's new. So at this point, I have this in an area called on-stage file. So these are things that at this point I have locally, but I don't have the intention to be pushed to the repositories, to be shared with anyone. If I want to share them, all the things I have to do is click here, stage selected, or I can even double click it. I double click it, no. I can press space. So when I move it up, what I'm doing is grouping all the files. So if I make 2 files, I'm grouping them. So my intention is to share them later, or at least back some work I've done. So for example, here I've changed the Swarman to have red show. So my intention is, for example, test doesn't have any meaning with the show, so I will not push that one. And yeah, I want to share that to the team that I changed the shows for the Swarman to be red, so I can create a description of what I've changed. It's similar to the so what I'm doing here is saying that this file I've changed will have this probably I could have different files, not only one, but what I'm saying here is that this change will have this comment. So later on in the history, if I make this comment, if I click on development, you will see that this new point in the history has been created. This is a commit. So what I've done is I've modified a file I've added a description about this file and created a commit. So as you see, when I click on development, it's showing me all this information. So this format has changed, and as you see, and there's a difference between origin development and development. So this is we are going to cover now. So this is all the thing we code, and well, this is sorry about. So right now I made a commit, and what I've changed is the history. So that's what development was before my commit, and now this is what is now. So going back to the presentation, there's two main topics we will need to cover. So there's commits. That's what I've just done. I created some file changes. I can, in a commit, there could be more than one file, but in this case, I've only changed one. And the changes could be add, modify, or delete. And all the commits has a parent. So in this case, when I created the format with red shoes, the parent was the previous development. So before I added red shoes, the format already existed and had all these things, and I just added red shoes. So when I added a point in the history, let's say a commit, the parent was in the graph. It's easy to see that you have here a parent. So when I click on the parent, I come back to this history. And so it's important to note that apart from this information, that every commit has a special code, so you can share with other teammates if they want to know where did you change something. So this is our unique IDs. But yeah, it's also important to distinguish with the parents. What I wanted to say here. That one thing to see is that and on every point in the history, you are only seeing the file changes. So this is showing me that the format has changed with a green color, showing me that I added red shows. If I click in the history, is showing me that I added, for example, that format div have that. But this is only showing, as before, is showing the modifications. But all the points in the history have all the repository in that history. So that's the main purpose of the control version. Probably that's a bit confusing, but what I'm saying is that when I was here, even if I jump to this commit, even I only see that here I have some properties changed, that this format has death, or the format start with 100 HP. If I discard my commits, well, if I want to jump here, I will do something you will see later. So I removed all the things I had locally. If I go here and I see on the repo that I have these changes on this commit, if you go here, you will see that all the files are. So that's one of the great important things on Git. So any point on the history you make, you have all a version of the project. So for example, this is the usual common branch where everything is updated. So in development, you have all the features that has been added to the project, and you have all the files. So you are not like having the modifications or whatever. You in your Explorer, you have all the files in that point. So if I zoom to the past, if I zoom here, so for example, here I merged the Archer, and I didn't have the Swarm and Death. If I zoom to another past I will show that later. If I jump to another point in the history, you will see that the Swarman has changed, and that's the great power of Git, that I can jump to any point in the history and recover all the files that there was. So, and also more important, I can come back to development again and have again the Archer. So if you take a look at the Swarman, for example, when I'm in development, I have these features, but if I jump to this other commit, the Swarman changes, and one important thing is that I will never lose my work, because it's always available in the history. And apart from the commits is what's called branching. So I already used the word. So apart from commits that are just file changes and they have a parent, there's another thing called branch. A branch is like a name you add to a commit. So for example, if I'm here in develop, well, I can do it again, but here here I created a branch. I think I have made a video. I will show it later. But every time you are on at some point at the history, you usually refer, instead of referring to a specific commit, instead of referring to the C6D whatever, you refer with a name. So if I'm in development, so it's the point in the history where we are going to merge everything. We don't want to refer to a specific point in the history. Let's say all the features were merged at the 28th of July. We want to say that we want to refer to development. So it's like all the features we are going to merge, and all the in the history will be available in that level. So every time we create a new commit, for example, as I did before, I can add reduce. If you take note, when I create a commit, I'm working on a branch. So I'm working on a label pointing to a commit, and probably that's a bit abstract. I don't know. I will try to make a better definition later on or whatever. But so when I create a commit, I'm adding a new point in the history. And what's important to note is I created a new file change, but the branch I'm working on has been also updated. So I created this commit that wasn't available before. Before I was at C6. Now I'm 0F, and I'm saying that the branch has to be updated with my new changes. So later on, when someone wants to go to the most updated branch, he will not refer to the old one. He will refer to this label. So what I'm doing with the commit is not only adding a file change, I'm also saying that these file changes are inside this branch. So the branch is like a grouping of features that we want to be updated together. So in this case, when I created the Swarman change, I'm saying that I want this Swarman change to be in development. So I'm saying that I want to update it. I want to the server development is also updated. And I will cover back to this, but I don't know if it's clear. So the basic definition is this: the commits are file changes, and they have a parent, and every commit have a file change, a copy of that changes, and also as it has a parent, all the project is available at this commit. So if I go to any commit of this, I'm not only going to have these file changes, as this has a parent, I can go back to history at that point, and I have all the project available at this point. And branches are just a naming for the commit. So every time I make changes, I want to instead of being referring to the history of all the commits I made, instead of being said, I made a commit, and you can go to commit 5. I'm saying I'm grouping all this in a branch. I'm saying that every commit I made will be added to this branch. So the branch is also updated to always point to the most updated commit I've made. Well, probably it's not a really standard definition, but I think you probably will understand, or trusting you will learn it. And also something I covered a little bit from the scratch from a top view is that there's a difference between remote and local. So as I said, I have two repos that are the same project, but they are two different folders in my computer. That's something you will not usually have. You don't usually have the remote server in your computer. It will be available on Git, but in this case, for learning purposes, it will be useful. So if you see, as you see, the local repository, so we went and referred the remote, has a tag before all the branches saying that if this branch is origin means it's in the server, and if it doesn't have origin, it says it's only local. So every time for example, in the previous case, I added red shows to the Swordman. What I've done is only local. So anyone that's connected to the server, if I go directly to the server, I don't see red shows here. So that from the development side, you only have to take care that there's a difference between the branches and the remote branches. For example, I have development in local, but development in remote. If you click here, you will always be able to jump to know what status everything. And if you click fetch, what you are doing actually is downloading all the remote changes. So if someone makes another change here, you will hear meaning to the server. You will when you click fetch, you will have it updated. So for example, if anyone makes another branch, I can do it here. Well, I can do it here. That's pointing to a really old, but I can do it. If someone is in remote, I will explain branches, how to create branches, but or branch. That's something you will not usually see, but if I'm simulating someone made a change indirectly on the server, so as I'm in the remote, I created another branch, and when I go local, I don't see that's anyone has made a really old branch. But if I click fetch, what this will happen is that here it appeared another branch that's here, and yeah, you when you click fetch, you will see that there's a branch. For example, in this case, I don't have the old branch in my computer. Well, I have it in the repo, but in the local branches it's not available. So I only see old branch. I don't have the origin. I don't have a version without the origin. So this means I don't have it locally. So if I click here, I can jump there. So what I'm doing is not when I click on a branch, I'm not downloading that branch because the downloading part is done in the fetch. As I said at the start of the presentation, Git, when you have Git, all these commands usually are local. So one of the only two remote commands probably are push or fetch. So when I fetch the repository, I have already downloaded the branch. And when I'm switching between branches, I'm doing it locally, so it doesn't have anything to do with the server. And yeah, that's the main difference in the history. Okay, a little bit explaining what's feature branching and why we do feature branching. So what I want to say here is what we usually do as game programmers is every time we make changes. For example, I will discard now the development changes I made. Here I'm removing the red shows. So when we usually code, for example, I have different units. I have a swarm and an archer. For example, if I want to add a new unit that's, for example, a troll, I create a new file. So it's like a copy of a swarm called troll. And instead of being working directly with development, what we do is creating a new branch. So we create a branch per feature, and this allows us to, at any point, don't mix things. So and the branch has a specific purpose, and we can also always refer to it at any point. So if we are working, for example, in a troll, instead of doing as I did before, just making a change and push it in development, what usually useful is to, before making the commit, go here and click on branch and add a name to the branch, troll unit, for example. And as you see, when I created the branch, the development branch and the troll branch are in the same commit, because I just created the branch in that commit. But when I make this commit, the new unit copied, and before adding any change, I usually have to make a comment. So anyway, later on, anyone can know what you done, why you did it. So I'm into the troll branch. When I make a commit, you will not see any difference here. But if you click here to go to history, you will see that the development is as it was before, but I have the troll unit with a commit added to the troll. And if I want, for example, make the troll, or I have a bug, for example, the troll has an incorrect name, and I want to add him 200 HP. And that's like we code, so you know what we do. We make a branch for the troll, and we keep modifying code files, and we keep adding commits to the branch. So we set troll name and added 200 FP. When I commit, as I said before, you will have this branch, and that's especially important to do a branch for feature, because at any point in the history, if I don't finish the unit and I need to fix something on the swarm, and I won't fix it here, because this branch is only for the troll. So if I want to fix something about the swarm, I will go to development, and here probably create another branch called swarm and fix, and here I will fix it. And that's something that I see that probably people that are not coders, they don't usually understand why, because they don't have to change a lot of files. They probably because they just change a binary file and they change it directly on development, and they want to push it. But it's important not to mix features, because if I change the swarm, for example, if I fix the swarm and I say no, it has 110 HP, and I add it to, before adding a commit, you have to put it on the staging file. So you can't have any pending files here, but what you want to push to commit have to be here. So that's especially important. Now I have two branches that are independent with the troll and the swarman. So if I made them together, I won't be able to finish one feature before the other, and I won't be able to actually use the version control correctly. So all the changes I made will be mixed, and yeah, that's somehow breaking the history and of your project, because if I made a feature but everything I want to do, at any point I will have everything covered. So I have the base, what's called the base of these two branches where they come from, and I can continue any one of these, and yeah, they won't mix it, so the history will be clear. And at any point, if the client told you, yeah, I want the troll to be merged in development, you can merge, and if you want to fix, you can merge the fix, but they are independent. Also important, as a developers, as we make file changes, so we usually touch not only a single file, we touch different of them. We usually make a lot of commits, but a lot of commits to a branch, and it's important, probably only for codes, but it's important as every time you have something that is a bug, something that, for example, compiles, or for example, in that case, I added a neutral unit. I have created the basic structural file. Just create a commit, and don't spend, for example, 3 days without committing anything, because at the end, during these 3 days, you have advanced on your work. So if you use the Git control version, you always will have some save points where you will be able to come back in history. So for example, if you lose, if for example your computer crashes or whatever, you will have like a backup. So you will have different points in the history where on the steps you made to, for example, create the troll unit. And yeah, so you are creating the history, and you will be able to come back to it. And also important to push it, because if you only commit, as I've said, and this troll unit is only local. So for example, if I stay here for a week, if I don't push it, this troll unit will only available on my computer. So here they don't know there's a troll. When we push a branch, what we are actually doing is sharing all this information to all the team members. So all these commits I created and the branch name now are available to everyone on the project. So here has appeared the troll unit because I've committed, and you also see here origin. So it's also important to push. And yeah, we don't usually keep branches that are merged in development when they are merged. So we usually delete it, because, for example, if I merge the troll unit to dev, it's like I don't want to continue working in the troll unit. If I later on need to add something to the troll, I won't. Probably is better to show it, but if I, for example, go to development, and at some point I merge the troll. I will show later how it's merged. But when I made a merge, well, probably I could revert it because I made something. I know. I'm okay. Let me. Yeah, I wanted to. I wanted to merge the troll into development, so I'm merging. So I'm clicking on the branch troll. I'm merging. I forgot to click here, so that's not important. But I prefer to show you here in the presentation that the difference is that now a new commit has been created with the merge, and because in the previous, well, probably I can show you, I could have shown you, but in the previous past and the previous step I did, the development branch just has been added here and the graph didn't change. But yeah, that's something visual. Well, what I wanted to say is, for example, if I merge the role, what we usually do is delete this branch, and if in the future you need to change something on the troll, don't go back to this troll past branch and continue doing things here. You probably could continue in development and create a new branch. Troll, for example, if I want, I don't know, change the weapon of the troll, I will prefer to have a new branch, and we will start again here. For example, here a junction with well, I don't know. If I add something, I will be adding this feature in another branch. So it's not required to keep branches per feature, rather than every time you work, create a branch, and when this merge, you can start from development again. So for example, here, change it. I'm changing the format, but anyway. For example, I wanted to show the troll, but yeah, doesn't matter. What I wanted to say is, if I change the troll here, don't go back here and continue making changes if you have already merged that into development. So the branch where everything is updated. Better create a new branch per feature, and also when I merge, it's not required. Because one of the problems about keeping branches forever is that branches get outdated. So, for example, if I made the troll 2 months ago, and I know someone tells me to change it, if I go to this branch and I start changing, probably in development, other people could have changed all the trolls things or other units or whatever. And if I try to keep with my original branch, I will not get any benefit from Git, because I'm continue working on a past history when I'm actually working on something I want to come back to something I want to do now, not in the past. So yeah, what's important is to remember that we are creating the history in Git. So every time we do something, usually go to development and create a branch every time something is new. I don't know if that's everything covered, but yeah, and that's, I think I made a video by showing mainly how to create commits, and every time you just remember that every time you make a branch, all the commits you are making on the branch are updated, pointing to the branch is updated pointing to the last commit you make. So for example, here I made a test branch and I added a commit. So if I continue editing more files or changing the same file, when I commit when I make another commit change on that file, the branch is updated to the new commit. So that's something working locally. So for the moment, it's something in my computer. So the test branch now has the commit 2, but before had commit 1. So just to let you know that branches are updated every time you commit something on that branch, the branch you are working on. Okay, probably the video. Yeah, that's a warning, because probably I've seen people having these issues about this. Is as I said, you have usually the history with different branches, so different features you have done in the project, and sometimes it could happen that you want to go to this commit or whatever, For example, if I click here, I'm clicking to a commit, not to a branch. So there's a difference because I could click here Swarm and Death. It's a branch I don't have in my computer. So if I click here, it's going to tell me, okay, you want to create to create a local branch from a remote branch. So that's the remote. That's the one I want to create. And it will create me a Swarm and Death branch that is pointing to the same branch in remote. So usually we have to have the same name in remote and origin. But if instead of clicking to a branch for error, I click to a commit that doesn't have a branch, what's going to show me is an error telling me that I'm switching to a commit. So if I do it, I won't be in any branch. That's called the head. So my head is now pointing to a commit. So if for error, I'm here in the troll. If I let me okay, yeah. So for example, I'm in that branch. I am in that commit. I'm not in a branch, and I start changing things in that unit or whatever, and I can actually commit here. It's not okay. I haven't solved it. For example, if I make changes, you will see that you don't have any branch highlighted, not bolded. So if I click in the history or on any other branch, you will see that you have head, but head is not a name. You have a different icon, so it's like a label. It's because all your work done here could be lost if for example, I try to switch to another of these branches I have local. My work has been lost now because I've made a commit on a non-existing branch, and the commit is still available on your computer, but you will have to do strange things with Git commands to recover that commit. But if you usually detect, I'm going to do the same again. I'm on a commit. If you are just at this point and you detect that you have made if you are at this point and you detect that you have made a change but you are on any branch, probably the easy solution before switching to another branch is just create a branch here. So what we are doing is adding putting a name to this commit. So we can say throw for example, and when we do it, I did that as a typo. What we are doing here is we are adding a name. So if I do the same as before, if I change branch, this branch will be still available because I've given him a name. So yeah, the easy solution is just to make, if you by error go to a head, if you click to a commit, just give it a name, and it will be easier to recover it. Because what's important is that every commit has a branch. Also, another thing that probably most of the artists I have they have problems about reset. Something, well, now I have a lot of branches, but for example, now I will revert development. Yeah, so now and in probably I will start from scratch. Don't look now. So for example, here I'm in the development. I have these files, and I will do the same process as before, but instead of adding a foreman, I can add a goblin, for example, and I click goblin, and yeah, use that. And I created a goblin. If by error I'm in development and I haven't created a branch, and I create it, as we've seen on the presentation, what I'm doing by this commit is updating my branch to point to the new commit. But that's something I don't want to do. I can do different things here. I can either create a branch here directly, so I will goblin branch. So what I'm doing is adding a name to this branch. But what's happening also is that the development branch has been updated to point to a commit I didn't want it. But anyway, as you see, the goblin branch is here. So it doesn't matter if the development is pointing here. I want the development to point to the original development. So one thing I can do is go to development and click on the original development or the parent. Yeah, I can click here on parent and click here and click reset to this branch, just reset current branch to this commit. So what I'm saying is I'm in development, I'm at this commit, but I wanted to development keep pointing to this one because I've already created a new goblin branch. So all I need to do is reset current branch to this commit, and this gives me different options. If I click hard, all the things will do is delete everything I have locally and just point development to here. If I click soft or mixed, will be the same, but all the commits you have made will be saved in the working copy. So if I, for example, do this, what happened is the development now is pointing to the original development. So the goblin branch is now as it was. But if I see, I still have the goblin here because I made a mixed reset. So I didn't want it to lose my commit. In that case, as I created a branch, probably the easier or the clear solution will be to do a hard because the change is already committed in a different branch name. But just to let you know that you can reset and do soft. Okay. What time is it? We still have time. I've been an hour. I will try to go fast because probably it's taking too long this. Okay, probably I will. Well, in this case, I will really quick because I'm finishing. Sorry for the delay. In this case, I wanted to show you that you can also do merges. So that's something we have seen probably an overview that you can, if you have different branches, you can merge them together. In that case, for example, in that case, the new Goblin unit is merged with development, I think. So what are you doing? When you merge, you are not losing the history. So anyway, you can go back. What are you doing is merging two different file changes. Pulling, I wanted also to show you that the pull is a button you have on Sourcetree. And when you click it, you're actually doing the fetch. So you are downloading first the server files and then merging because it automatically takes the commits from the repo from the server and merges with you. If you can also have conflicts when you pull, but yeah, is that just to let you know that pull is also doing that. And also important about artists that there's Git LFS. That is the same. Is the thing that when, as I said, every time you do a fetch, you are not only downloading your branches, you are downloading all the server things. So if you make a change to an image, as Git works, it will make a copy of that file. So the original image and the new image will be all in the server. so that will make the repo really big. That's a tricky solution they added to Git, but it's just instead of having the images in the commit, the images are saved in a different server. So every time you do a fetch, you are not downloading all the images in the project. You are only downloading a commit where they say that in this commit they wanted an image that is available somewhere else. So they change a little bit the way files are saved. Instead of being available on the commit, they are available when you're branching.